look to the stars to understand our place in the universe, but what if the cosmos could also tell us about our health? Imagine a future where satellites orbiting Earth could detect diseases in their early stages. This isn't science fiction, but a burgeoning field with the potential to revolutionize healthcare. This new frontier of medicine relies on the fact that our bodies are constantly communicating, sending out subtle signals that reflect our inner workings. By learning to read these signals, we can gain valuable insights into our health and well-being. And what better vantage point to observe these signals than from space? Our cells communicate using a complex language of chemicals. When we're sick, this communication changes, producing telltale signs that can be detected. Two such chemicals are lactic acid and ethylene. Lactic acid builds up in our muscles during strenuous activity, a sign of anaerobic respiration. Ethylene, a plant hormone, is also produced in small amounts by our bodies, potentially linked to inflammation and disease. Satellites equipped with advanced sensors can detect these chemical messengers even in minute quantities. For example, the European Space Agency's Sentinel-5P satellite can monitor atmospheric gases including ethylene with remarkable precision. By analyzing these data, scientists can potentially identify areas where disease outbreaks are occurring or are likely to occur. While the potential of this technology is immense, challenges remain. Distinguishing between signals from the human body and those from other sources like pollution or volcanic activity is crucial. Moreover, interpreting the data requires sophisticated algorithms and a deep understanding of the complex interplay between our biology and the environment. Ethical considerations are also paramount. Ensuring privacy and data security is essential, as is preventing the misuse of this technology for surveillance or discrimination. Addressing these challenges will require collaboration between scientists, policymakers, and the public. The applications of space-based disease detection are vast. Imagine detecting cancer in its earliest stages by monitoring changes in ethylene levels, or identifying athletes at risk of injury by tracking lactic acid buildup. In disaster zones, this technology could help locate survivors by detecting their body heat or the chemicals released in the aftermath of a traumatic event. The possibilities are as limitless as the cosmos itself. By combining the power of satellite technology with our understanding of the human body, we're embarking on a new era of healthcare, one that promises to transform the way we diagnose, treat, and prevent diseases.